In this question, you are given the volume and molarity for not just one, but for both reactants, and then asked for the theoretical yield of one of the products. This is a classic limiting reagent problem. In this case, we first need moles for both reagents. To do that, we got molarity here equals moles over volume in liters. If we rearrange that, we get moles equals molarity times the volume in liters, and we'll find the moles of both reagents here. So we'll start with the MgCl2 here, and for the MgCl2, the molarity here is 0.4 molar. So, and the liters, 100 milliliters divided by 1,000 is 0.1 liters. And this gets us 0.04 moles. And again, that's for the MgCl2. Now, if we do the same thing for the NaOH, in this case, it's 0.1 molar. And 500 milliliters, which again, divided by 1,000 is 0.5 liters, which is going to get us 0.05 moles of NaOH. Now to find the limiting reagent from these, we're going to divide each of these number of moles by the coefficient in the balanced reaction. So for MgCl2, we divide by 1. So for NaOH, we'll divide by 2. And whichever number comes out smaller is the limiting reagent here. And 0.04 over 1 is 0.04. 0.05 over 2 is 0.025. And that's going to be the smaller number. And that's going to mean here that our NaOH is our limiting reagent. We'll use that then to calculate the theoretical yield. So again, we'll start with that 0.05 moles of NaOH, and then we need a mole-to-mole ratio here to get that to moles of magnesium hydroxide. So MgOH2 relative to moles of NaOH, and this mole-to-mole ratio is just the coefficients in the balanced reaction. It's 1 mole of MgOH2 for every 2 moles of NaOH, so 1 over 2 in this case. But that'd get us moles of MgOH2, but all the answer choices here are in grams, so we'll take this a step further and use the molar mass here. So we'll put 1 mole of magnesium hydroxide in the denominator, so those cancel, and that molar mass, if you take and add it up, is 58.3 grams magnesium hydroxide. Cool, and if you're doing this with a calculator, great. You should get this coming out to right around 1.5 grams. Now, if you're doing this without a calculator, so I'll probably do a little bit of rounding here. So we've got 0.05, so times 60, all divided by 2. In this case, a couple different approaches we can take to this. I'm like taking and dividing the 60 by 2, and so we'll have 0.05 times 30. So, and 0.05 is the same thing as 1/20th, and 30 over 20 is 1.5, gets us to the same place.